All right, here we are in Objective 3 of Power Focus Area 7. We're going to mostly discuss Newton's first law today. A quick review of some things we should know by now that tie in with his first law. And the first question up there is, what is force? If you remember back, I think, to Power Focus Area 5, we said a force is simply a push or a pull. So any object that is being pushed or pulled is being pushed or pulled by a force. Remember with our free body diagrams, gravity was a force. We had applied force, the normal force, friction was a force, all those things because they push and pull objects. And there's some common examples: wind pushing a flag, a magnet pulling iron towards it, the pictures of these guys pushing and pulling carts. All of those would be examples of force. Net force is the combination of all forces acting on an object. So if you've ever had a paycheck yet, you're going to see a net and a gross pay for yourself for the week or 2 weeks that you worked. And if you notice, the gross pay is how much you earn. So if you make $10 an hour, you work 10 hours, you made $100. However, your net pay is always less because they take things out like Social Security and taxes and eventually insurance. So your net force is kind of your pay, or net pay is your pay after all those things are taken out. Same thing with net force. When you add up all the different forces pulling in different directions, what's left is the net force. If the forces are in the same direction, so you and I are both pushing a box together because it's so heavy, then we just add the force to form the net force. If the forces are going in opposite directions, maybe we're having a tug of war. I'm trying to pull you past the middle, you're trying to pull me past the middle, then we have to subtract the two forces. And whichever force is larger, that's the direction the object would go. So those are kind of your rules for forming net forces. Make sure that you put this in your notes. Press pause if you need to, because I'm going to skip ahead. So again, net force, we said, if you look at this, we have 4 horses, and all of them are pulling in the same direction, actually with the same strength according to these arrows, these vectors. So because they're pulling in the same direction, to find the net force, we would just add the force of the 4 horses together. And in this instance, the wagon would move to the left because all the force is moving to the left, so we just add them together. In this picture, we have 2 horses now pulling toward the left with the same amount of force, 2 pulling toward the right with the same amount of force. So it's kind of 2 to the left, 2 to the right, and that would end up with a net force of 0, which means this wagon wouldn't move at all, which we see again in the picture. These 2 boys are pushing in opposite directions. You can see by the size of the arrow that it's the same force, so that door was not going to move. These are called balanced forces, which makes sense because things that are balanced are even. So these forces are the same strength in opposite directions, so everything's balanced. And as long as everything's balanced, there will be no movement. What about in this case? One of the boys now is pushing with more force than the other. You can see here he has much more force. He's using 2 hands. This boy's only using 1. Well, remember, opposite direction forces, we subtract them. So this is about half that size. So we can kind of cancel that half out, but there's still force going to the right, so that will move. The door will move to the right. And this is what happens when you have net forces that aren't 0. So instead of a balanced force, these are called unbalanced forces. So make sure you add all this to your notes. Pause, you probably will need to because I'm going to skip ahead in like 2 seconds. So press pause to get this into your notes. Before we mention the first law, there's a little bit more background that we need. Friction, we've mentioned it before, especially in Power Focus Area 5. Just a reminder though, it's the force that acts to resist movement between any objects that are touching. So whenever objects touch, friction is acting in the opposite direction that the object is moving. So your car, you see in the picture, the car is moving, let's just say this taxi in the back there with this car in the back. This car is moving forward, so friction is acting backwards on the tire. Friction between the tire and the ground. Notice how I drew my arrows. The car has plenty force to move forward, so I made my friction force that's going opposite a lot smaller. But friction is that force that opposes motion between any objects that touch, and it always has some thermal energy. Inertia is a new vocabulary word, and that's the tendency of an object to resist a change in motion. In other words, whatever an object is doing, sitting still or moving, it wants to keep doing that. And inertia is that tendency that it will keep doing that. Every object that you look around in your room that's not moving, it'll never move due to inertia unless some force makes it. And every object in the world that's moving will keep moving forever unless a force causes it to stop. We know eventually a car would run out of gas and eventually it would stop on its own. And the reason it would stop is due to friction. That's the force that stops it. If there were no friction, the car would go forever in a straight line. And a little side note on inertia, the more mass an object has, the more inertia it has, which makes sense. If something is moving, it's harder to stop it if it's heavy. Or if something is sitting still, it's harder to move it if it's heavy, it has more mass. And that's due to its inertia, its resistance. It doesn't want to change what it's doing. Go ahead, press pause and add this to your notes. So finally, to Newton's first law, one of the big ideas in this power focus area. His first law, and I'm sure you've heard it before, says an object at rest will stay at rest, or an object in motion will stay in motion unless acted upon by an unbalanced force. Notice we have to say unbalanced, because if a balanced force acts on an object, we said it doesn't change anything. The net force is 0 and it would stay the same. So another way of restating this law is it's the law of inertia. First law and law of inertia are the same thing. Remember, inertia means objects want to keep doing what they're doing. So if they're at rest, they're going to stay at rest. If they're in motion, they're going to stay in motion unless that unbalanced force moves it. So here's an example. We see this soccer ball sitting up here at the top left. It's at rest. It's going to stay at rest. Inertia says that ball wants to stay there, never moving, and it will stay there, never moving, unless an unbalanced force acts on it. It could be a big gust of wind, or in this case, the unbalanced force is somebody's going to apply a force with their foot and kick it. Well, once it starts moving, it's going to move in this same direction at the same speed it starts forever, unless an unbalanced force stops it. In this case, we see the net stops it, but even if the net didn't stop it, no matter how strong this kick is, we know the ball would stop. And the reason is the unbalanced force would be a combination of gravity pulling it down and air resistance slowing it up. So go ahead and pause while you put this in your notes. Now for this part, practice. Try to match these words with these definitions. And if you want, maybe just draw like an arrow, and I'm not even looking if this is right. And then the next slide will show you if you were right or wrong. So go ahead, press pause here while you practice. And then the next slide will show your answers. And if you have any wrong, you can correct them. So press pause now. Hopefully you got all 7 right. If not, fix them here so you can press pause if you need to fix them. And here we have some practice questions. So I would pause after I read these so you can think of the answer before we give them to you. You try to push a desk across the floor in one direction, but a friend is trying to push it in the opposite direction. As a result, the desk doesn't move. What kind of force is this? Press pause while you think. It's a balanced force. We said it doesn't move. Anytime something does not move, it's a balanced force. If it would have moved in the direction of the stronger force, then that would be unbalanced. Other practice questions. What happens anytime there are unbalanced forces acting on an object? In other words, the net force is not 0. Press pause while you think. We said the object would move, and it would move in the direction of the stronger force. Last practice question. Press pause if you need to, or look back in your notes so you can think of Newton's first law. And we said that's the law of inertia, the one that says objects will keep doing what they're doing, staying at rest or in motion forever, unless an unbalanced force acts on them. And that's all of Objective 3.